Okay, this is old electronics fan, and I have on my bench today this little Ward's Airline compact radio, very compact. This is a model 14BR-523A, or, it's got two versions apparently, 14BR-692A, and I don't remember, does it tell me on here? I don't see it. Well, anyway. Okay, I'm inserting this part because I got a little bit confused. Number one, I forgot that the tube chart lineup on the bottom of the radio also gave me the model number. Of course, that'd be something helpful to know. If you just paid attention and looked, oh, that's got to be glued back on. It's coming loose. Oh dear. Alright, actually I already glued this one because that was doing the same thing. I digress. Alright, so the model number on this is actually a 521A, 14BR-521A. So how come I got so confused with the other circuit diagram? Well, there's a good reason for that. Let me back out here so we can see everything. Alright. So this is the 521A circuit diagram. But, and this is why I wanted, okay, let me explain. This is a slug-tuned radio, and maybe I didn't need it, but this circuit diagram did not have the alignment information. This is actually, if you look at this is a 1942 manual of the 1942 most popular service diagrams. So this radio is actually, my radio is actually newer than this one, because this one is printed July of 41. And it doesn't say what the other one says. But anyhow. So this is a slightly older radio, a year earlier. It's not the same radio because it has a turntable. It's got a field coil speaker. Apparently between 41 and 42 they got away from the field coil speakers. At least they did on this model compared to mine. So with this slug tuning, I wanted information that would help me to properly align this. And that's what this contained. So I was lucky I found this. I don't remember how I found it, but I was happy to get it because the alignment instructions seemed to work perfectly fine for my newer radio. So I spotted this circuit diagram first in my collection of circuit diagrams for this radio, and so I started off thinking that my radio was the version mentioned here, the 523 or 692, and of course it is not. So anyway, that's where my confusion lay, and forgetting to look on the bottom. And I've been used to looking on the chassis, who knows why, for the model number, and sometimes it's there. But it also makes sense to look on the case and see if the tube chart can also tell you what you want to know. And if you do that, you avoid the confusion that I encountered. Okay, so this radio's been around the block a few times. It's got a crack right there. Yes, it's got a crack right there. These knobs came out from something else that I happen to have around. This plastic dial is actually shrunk, and I'm trying to still figure out what I want to do with that, because it no longer secures itself to the little, in fact, maybe you can see that little line right there. This used to clip into place. It doesn't anymore, because at least not on both ends at the same time. And let's see, here's the back side of this little thing. There's the antenna hookup. In fact, this whole plate is part of the antenna circuit because it plugs in. There's a little connector right here. When this pushes in, oh, come on, right. It makes contact with the antenna connection inside the chassis and completes the circuit for the antenna. This side, I think, is insulated from the chassis. You also see that it's got a piece missing here. I'm considering what I might want to do with that. I'm probably, which I don't want to, there are different ways. You can use body filler, different things. I have fiberglass style filler and I have fiberglass cloth. So I can reinforce this, then I can fill it in and shape it. And then ultimately probably paint it, and I'll have to make sure this crack gets repaired because it is still cracked and still loose. This radio has played since I've owned it. I was curious to see what the whether or not the radio would even work. So I hooked it on my dim bulb, which is hiding back there behind the mist. Where are you? Where's my dim bulb? There you are. And so I used that to check this out. And let's see. So I'm going to take a peek inside here, show you what we've got. And this just pops loose. Come on, come on. And you. All right, that's it. This has a date on the schematic of July, if it's going to focus, July 1941. And you can see from the tubes that is definitely about that vintage. Now, let me remove the knobs from the front, take a peek inside. Now, as I was saying earlier, this radio has played, and it does play. The thing about this is it doesn't play very well. It's kind of tinny, it doesn't sound great. So I'm fairly certain that this thing needs some serious help. And I recall, I'll get my screwdriver, that this thing was loaded with bumblebees. And if you've been around the old radio hobby any length of time, you will know that bumblebees don't exactly have a sterling reputation. They really, I mean, they were advertised like the greatest thing since sliced bread. They were supposed to be the be-all and end-all of reliable capacitors. Unfortunately, it turned out not to be so. Not exactly sure why. Because they are sealed, they're plastic. You can see this is, now let's see. Let's throw some light in there. Dusty, dirty. There's nothing really going on. There is a chart on the bottom, as I recall. And, yeah. And it's 2 basic 5 tube. They're all lined right up. This, let's see, no, 105 AC or DC. Of course, it's series string, so it could go either way. If it doesn't operate in 1 minute on direct current, reverse the plug. Polarity matters. Alright, so put that aside for a minute. Throw the screws and the knobs in there. Put that in there. Okay, put that out of the way. Now, okay. I guess I should pay more attention to my camera. Alright, so there it is. It's got a minor little ding on the speaker. Oh, come on. It's hard to keep track of. As you can see, this thing is just barely sitting there. I still haven't figured out what I want to do with that. I toyed with the idea of just using maybe some silicone and getting it planted where I want it and letting it stay there. And this isn't exactly what you call a high-end radio. And it's not in very good shape. But let's take a look underneath. Let's see here. Alright, let's throw some more light on there. And one of the things I was interested in about this was the tuning. It uses slug tuning. See if I can. It seems to work quite well. It moves smoothly. Some of these old radios don't work all that great. The tuning is a little bit iffy. But what I really wanted to get at was this right here. All right. Bumblebee. So there's 1, 2, 3, 4, 5. 5? Yeah, there's 5 of them in here. And so one of I wanted to do was, notice that this is the power cord that's been hacked off. I was the one who did that because the insulation was, I gotta remember where I am on this. Okay, this is the power cord. I cut this off. The insulation on this is shot. Basically, it was bare wire. So when I hooked it up, I was extremely careful. I had my dim bulb on it, and but I wanted to listen to it to see what it would do, if it would do anything. And it did play. So I was kind of happy with that, and I thought, well, okay, so it's worth doing something with. Oh, and it has a paper cap there. This is part of the volume circuit. Dog bones. Got some, I assume these are mica capacitors here. Let's see. Come on, where are you? Okay, so that looks like a mica right there. You can get fooled by those because they also make paper caps that look like mica, and I have a feeling, because of where this one is, this might be paper. Type D, or type O rather. I'm not familiar with the types on these. So, it's an old radio, very, 1940s, and it's fascinating. This is a coil. Let me back out here. I get used to this. This camera is actually new to me, and I'm getting used to using it. And so this right here is actually a coil. Basically, it's just wound up and wrapped up with this piece of paper, and adhesive apparently was put on it. It's still there. So I'm going to put a new cord on this, and what I want to do, yes. Alright, and I want to look at, now here's where it gets interesting. Let's take a look at the schematic. Hopefully I can show you this. Okay, I wanted to look at the circuit diagram. I want to show you what I'm going to do. I've already drawn the changes I'm going to make. And so this is where the on-off switch is right now. This is where it's going to be when I get down. The reason I'm doing this is because this is the B- wire. So you got a 50-50 chance of this B- wire having full 120 volts on it. And that's a problem because if you follow this B- wire over and you have these two connections coming off from it, one goes through this 150 k ohm resistor, and this other one goes through this C6, it's 1.5 microfarad, and this little coil right here, which is an RF choke. This RF choke, it's like 1 or 2 ohms, very low. It's not going to resist much of anything. It's designed mainly to, I believe, deal with any noise coming in through the chassis. So this capacitor is going to allow AC to get through enough that you're going to feel it if you have your hand on the chassis or one of the screws. So you're picking the radio up and your hand is touching the back of the chassis, which with this radio is very easy to do, and you touch the ground. Say days of an old radiator, those old radiators were grounds. You touch the radio and touch that radiator, it would know it, it would bite you. So my plan is to change things around, so that with this polarized cord, this line is always going to be the hot line, this is always going to be the neutral. And of course that works as long as the outlet is properly wired. Unfortunately, there are people who do wiring in their homes and they don't know what they're doing and they wire it incorrectly. So that kind of defeats the purpose of having a polarized plug. But most of the time it's going to make this radio much safer. So I'll be back and I'll show you what I did. Okay, so here we are. I've got this power cord that was in my junk box. I have this terminal strip that was in my junk box. I've rewired the radio. There were actually 4 wires that were on the on-off switch, so I've moved those over here. The neutral lead from my power cord is going there. The hot lead is going to the on-off switch. And then the wire from the on-off switch is going down to the 35Z5. So the end result, of course, is now I have a much safer radio. I don't have to worry about the chassis getting hot. And the way this thing is wired, the antenna circuit is actually on the B- line too. So, and there are some capacitors in between the B- and the tuning coil and the antenna. So you wouldn't get the full AC current, but you could get bit. So now that's no longer an issue. So I'm pretty happy about that. I did check. Now, of course, there's no longer any AC voltage getting to the chassis. That's a thing of the past. As long as the outlet is properly wired. Sadly, some people don't wire their outlets correctly. They don't know what they're doing, and they wire wire the outlets themselves, and they get it wrong, which is kind of scary, but that's just the way it is. So, apart from that, though, that makes this radio a whole lot safer. Okay, I was going to do a final voltage check. I had printed this from the schematic. I enlarged it so it would be easier to see. And I was also experimenting with, or I was comparing, let's bring this back out a little bit. I was comparing this radio with this one. And why would I do that? Well, the front end of both of these radios is very similar if you look at the schematics. Not the same, obviously. The Airline radio here, or this radio here, General Electric actually, has a better antenna. It's got the rod antenna in there, which obviously helps quite a bit. It's newer, so the tubes might be healthier. This is an older unit. This has the miniature tubes in it. This has the regular full-size tubes in it. This one right here. It's got the older. The radio itself is older. So anyway, so all I had to do was tap the volume control on it, and every time I did, I get all kind of static and noise. And now one of the things I do know about these resistors, these old dog bones, is that they're prone to fail on the ends. And notice something. All I have to do is touch that. I touch this end of this, that's not a problem. I'm looking at the solder joints, those all look good. I tap this one, I'm fine. Up here, tap the one up here, that one's fine. I tap other things, everything seems happy. And that little guy doesn't seem to be very happy. But that sure looks like my culprit. Like I said, since I know these are prone to fail, that's interesting. Oh, that's interesting. What's going on here? I think we need to explore that better, more too. Huh. Well, here's what I'm going to do. I'm not sure what's happening. Maybe it's just vibrating through here and hitting there. I'm going to replace that resistor, and then I'm going to come back and see if that solved my problem. If not, we'll be digging deeper, and I'll also be looking at the solder joint on that. But I have a feeling that I'm still dealing with that, because I'm getting the same response there, and I'm betting, yeah, I think I'm just, well, we'll see. Clearly, when you all I have to do is touch that, all I have to do is put pressure on it, and it quiets down. So, let's see what happens. Okay, well, you probably have noticed that this is still here. And you notice there's no more noise. Now, there are a couple of things. With this style tube socket, one of the things that can happen with them is, I don't know if I can get a good spot to point it out. Well, let's see if I can explain. Let's see, here's a pin. Alright, so here you've got, here's a socket, you've got a tab. It goes down, goes under the material that forms the socket and then comes up here to the pin. What happens with this style of socket is sometimes right here where this connection hits the material, right there where it bends and heads over to the pin, it will break off right at that point. It will crack, and you won't necessarily see it. You will find it when you start moving it around and you start making noise, and bad things happen. But you can't always spot it right away. Now, so what did I do to this? Well, I did a couple of things. Over here on this, and you can't really see because that's in the way, I have a J-hook. The reason, this is a used capacitor. I tested it. It tests like new. I didn't have something around at the time. This is going to be a shelf clean anyhow. So I J-hooked this connection and then soldered in over here with a piece of extension wire. I looked at that solder joint and I said, yeah, maybe that could be my problem, because that is one of the things that comes off from this connection. I went up here, and there's a connection up here that I was tapping earlier where the power cord connects to. I resoldered that. Then I put deoxit on the pins of this socket. I also used a pair of pliers to bend the pin, the part that grips the pin, bend it in a little bit to give it a little bit tighter grip. And after I put deoxit on it, I moved the tube in and out. My guess is that the socket was dirty. I didn't notice it before when I was working on it. And I just simply had a bad connection going to one of the pins. The reason I just opted to not just automatically replace this, apart from the fact that I don't have a replacement, it happens to be a 5 meg ohm resistor, and for whatever reason I don't seem to happen to have one of those around. I could probably come up with something that will be close. But I don't know if you can see, but this little thing looks pristine, and usually, I don't know if I can, I guess it's alright. Usually somewhere on the end here, where how this works is the wire is wrapped, there's a wire that actually wraps around, this connection wire comes up, it wraps around the end of the resistive material. on both ends. And what will frequently happen is that this bond here between the wire and the resistor will let loose, and then when you jiggle it at all, as you can see, it's not doing a bad thing at all. It's no static, no noise, no nothing, no hum. It's just all better. You move the resistor, and this wire will start shifting on this connection wire will start moving on the resistor, making all that racket that we were hearing. But I kept looking. Sometimes there's a hint right where the paint joints, where the where the paint on the resistor hits the connection wire. You'll see a crack in the paint. Sometimes it's too fine to be seen. But I looked at that and I said, that looks awfully clean. I don't see anything really wrong with that. I mean, that doesn't mean, oh, don't do that. And I guess that's about as far as we're going to get. Are we really going to do that? Come on. Okay. All right. That looks pretty good. This all looks, there just was no indication whatsoever that this paint had cracked here or here, here or here. And I know better than to say, yeah, that's still not the problem. But that's what made me start looking elsewhere. And I did put my meter across this. I have an analog meter. Yeah, let's back out here so we can see it. This is an old Micronta, sold by Radio Shack, analog meter. And I use this sometimes when I have flaky connections now. And the reason I use that is because it's analog. Number one, it doesn't have to think about it. There's no electronics to think about anything with. So when you have a flaky connection, let me see if I turn the meter on. It helps. Of course, this thing, the reason that this isn't in, well, there's a number of reasons why I don't actively use this. It's tired and old. But you do, if you just tap, this is simulating a faulty connection, and you can see it in the needle, and it's instant response. The minute I touch that, the needle dances. So that's why I use that. It's no longer trustworthy as an accurate instrument of measure. Sorry about blocking your view with my elbow. But so I put it on here, and I tapped it, and I jiggled it, and I moved it, and I got nothing. So I thought, I wonder if it is just the socket. Because it's so easy to say, okay, this is an old dog bone resistor. It's going to die, or it has died, and just go ahead and replace it. I measured this with a meter. This thing is dead on. It's as accurate as a brand new resistor. And I went around tapping on the others. And all of these that are still in here I've tested, and they're right on spec. So I was kind of reluctant to replace it, especially since it didn't seem like I had to. So like I said, the solder joints down here looked good. The solder joint over here looked iffy. I resoldered it. I cleaned the socket. I tightened the pins. I moved the tube in and out after I did the cleaning. And as you can see, I can tap on it. I can tap on it. Nothing. Absolutely quiet. So, I guess I dodged the bullet because I was all set to just, in fact I had my solder iron all warmed up. Well, I was going to resolder joints anyway, but I was all set to just go in there and take that out and replace it. I also thought maybe, I didn't like the way this pin was moving, but I couldn't determine for sure that it was flaky, and as you can see I can do whatever I want to with it and it doesn't do anything bad. So troubleshooting static or intermittence like this can be a royal pain in the neck. But if you take the time to really pay attention to what's going on, try the easy stuff first. It was definitely easier to throw some deoxit on that socket and tighten the pins and test it with the tube after moving the tube in and out to try to clean the contacts. It was definitely easier to do that and go and replace this resistor and go hunting for one, if I even have one to find. So I guess the bottom line is try the easy stuff first, and then go after the other things. And don't jump to conclusions. I had pretty much jumped to conclusions that resistor was bad. Thankfully, I thought about it a little bit more and discovered that no, that resistor wasn't bad, it was another problem. So like I said, I don't know if I had a flaky solder joint over here, whoops, over here, or up there, which you can't, up there. I don't think so. This one maybe, this one I don't think so. I just redid that just to make sure. And I know these solder joints are good. I look at them and there's no hint that I made a cold solder joint or anything like that. So, which is also a mistake you can make. I have a little I think 601 FM tuner, and I did make that mistake. I replaced a component, and the way it was wired was the part that I was replacing was soldered on the end, and further down the pin were other components that were attached. Well, I heated the solder up just enough so that this area down here wasn't quite flowing, but it was still soft enough to crack, and that's what happened. This part of the solder joint was good. Down here I had a wire floating loose because I actually moved it, of course, when I was installing this, and of course it caused me no end of headaches trying to find out what went wrong. So one of the things I've learned, I'll just throw this in, I know I'm rattling along on here. Make sure when you heat one of these, when you have multiple items on a pin, make sure you heat the whole pin up and make sure that all the solder on the pin is flowing. I didn't do that. I just quickly got in there, got the bad piece out, got the new one in, soldered it, using just enough time to solder this end and make it flow properly. And this was a good joint. Unfortunately back here, which you wouldn't believe would happen, it had only started to flow and it cracked. Excuse me. So just something else to look out for. So now this thing is once again working properly. Okay, now that we've gotten rid of the static problem and the radio's working probably about as well as it's going to, we're going to go to part 2 because I'm going to end this video here. And in part 2 we're going to compare this 1942 very inexpensive portable little radio, compact little radio for sure, against a 1960 radio, which is most likely to be a more expensive model. But what's interesting is that the circuit diagrams show a very similar design, I guess if you will, between the two radios. But again, this is probably, even if you adjust it for the difference in ages, this radio probably costs a lot less than the other radio that I will be comparing it to. But anyway, hopefully that'll be fun to look at, and I will also be I'll be evaluating capacitors using my C3, which I just finished repairing, and my C3 capacitor tester, and VTVM, and to see if the I kind of think the VTVMs, my VTVM is a good, quick, easy way and a very effective way to see how well or how healthy paper capacitors are. Unless you're dealing with shorted electrolytics, the VTVM is not going to be as good a tool as, say, the C3 or some of the other tools you can use, like ESR measuring devices or whatever. So anyway, I hope you'll join me for part 2. Thank you for watching part 1.